Whoa.
Oh.
I don't understand how a submarine can float 1 minute and sink the next.
Oh, well, submarines can control their depth in the water by changing the amount of water or air they have inside of them, just like a fish.
What? How does that work?
Well, by adding or removing water, an object can change its buoyancy by changing its density.
Oh, wow. You have to show me.
Well, how about you give me your water bottle?
Yeah?
And I'll show you how you can make a cool submarine out of it.
Sweet.
How do submarines and fish control their depth in the water? What forces influence whether a submarine sinks or floats? How does a submarine achieve neutral buoyancy? Let's find out.
Hey everybody, welcome back to Moon Kong Simple Science. Submarines are amazing machines. People can live inside of them for months at a time, and they can move wherever they want inside the water. Now you might be surprised to know that both fish and submarines use the same mechanics, the same principles, to move to any depth they want to in the water. And that's what we're going to talk about today. Now for today's experiments, I've created a simple submarine. Now on the bottom we have a weight with a couple of holes to let water move in and out. Now I can control the amount of air inside of the submarine by sucking or blowing on this plastic tube. Now let's move on to your first experiment. Now what do you think will happen when I put this empty submarine on top of our water? Let's find out. So as you can see, our submarine floats on water. Now there are two forces acting on our submarine right now. The force of gravity is pushing downwards according to its mass. On the other hand, a force called the buoyant force is pushing upwards on our submarine according to its volume. So right now, the buoyant force is greater than the force of gravity. So the submarine floats. Now we call this positive buoyancy. Okay, let's move on to your second experiment. Now what do you think will happen when I suck on this straw to remove the air from inside the submarine and replace it with water? Well, let's find out. Okay, so let's take a close look there. Now you see that our submarine has sank to the bottom of the water. As we replace the air inside with water, we increase the mass of our submarine. As we did this, we increased the force of gravity. Now the gravity force is much greater than the buoyant force, and the submarine sinks. Now we can express the relationship between mass and volume of an object by using a term we call density. If an object is denser than water, it sinks in it. However, if an object is less dense than water, it will float on top of it. So right now, the average density of our submarine is greater than water. Okay, let's move on to your third experiment. So this time, I'm going to try to make the density of the submarine the same as the density of the water around it. Now, what do you think will happen when I do that this time? Well, let's find out. Okay, so let's take a closer look at this. So now what you see is that our submarine isn't floating or sinking at all. It is hovering somewhere in the middle of the water. Now at this point, the density of our submarine is the same as the water around it. The buoyancy force and the gravity force are both the same, so it doesn't move up or down. Now, submarines and fish can change the amount of air inside of them to adjust their buoyancies just like this. When you are able to hover in one depth of the water, we call this neutral buoyancy. Okay, so let's review what we've learned today. Submarines and fish exchange water and air to control their buoyancies and densities. The buoyant force pushes up on an object in water, while the force of gravity pushes down. Now, the balance between the buoyant and gravity forces is determined by an object's density. An object that is more dense than water sinks, while an object that is less dense than water floats. Well, that's all the time we have for today. I hope you had fun with submarines, and I will see you next time. Goodbye.